Hi, welcome to this video. It's going to show you how to find the surface area of a cone. There's two pieces of information that you need to find the surface area of a cone. So first, let's write down what the formula is for surface area. So for surface area of a cone, it's pi r squared. That will get you the area of this part, the circular piece, plus pi r S. What does the S stand for? The S stands for the slant height, which is, this cone here isn't actually standing up, but it's a slant height. It's the slanted measurement of the cone part. That differentiates from, this is something we don't need for the surface area, but just so, why do they call it S? Because there is a height that's perpendicular to that base there. That would usually be called H in that case, but we don't have to worry about that for surface area of a cone. I just wanted to clarify that. So what I recommend doing is, once you know what the radius is and what you know, and once you know what the slant height is, just writing out what you're going to type in your calculator. I would recommend trying to find a calculator that will give you the order of operations, so you can just enter everything in at once and hit enter and it will do it for you. Sometimes calculators don't do that though. So you need to kind of remember to do the squaring first. And then this multiplication, that multiplication, and then finally adding the two together. So that's just something that you're going to have to remember to do if you do have a calculator that won't perform the order of operations for you. So before we get started on this problem, I just want to remind you that surface area means like covering something. So if we're going to cover this cone, not just the cone part here, but also the base as well. That's what our surface area is going to be. Okay, so what we're going to do, if we look at this cone here, what are we going to type into our calculator? We're going to type in pi. Our radius is 3. That's what the r stands for. We're going to have to square that. Plus, and then we're going to do pi. And again, the radius is 3, and the slant height is 9.5. Okay, so what we're going to do is grab a calculator, and we're going to put those values in, and then times pi. All right. And when you do that out in your calculator, you should get 117.75. And we have to look at our units. The units that they gave us were yards. And whenever we're using area, whether it's surface area, lateral area, or just area, we need to have units squared in our answer. The way that I remember it personally is I know that there's two A's in area. So my exponent on the units only is going to be a squared. All right, so that's that answer. Let's take a look at another problem. And if you're feeling confident at any time in this video, I would say hit pause, do a problem out, and then hit play and see if you get the right answer. All right, so this top cone here, we have the radius is given to us as 9 centimeters. And again, we have the slant height is 20.1 centimeters. So we have pi r squared plus pi r s. So what are we going to type in our calculator? We're going to type in 3.14 times the radius squared plus 3.14 times, again, the radius is 9, and our slant height is 20.1. All right, and again, I would just grab a calculator and type it all in. And when you get this one all calculated out, you should get 822.366. This will, usually if they have you use 3.14 as pi, they're going to ask you to round to the nearest hundredth, which is 2 decimal points. So the way that works is if we look at our decimal here, we have 0.366. This is our hundredths place, so we're going to carry it out that far. We have to look at the number right behind it. Now this 6 here is bigger than 5, so any number 5 or bigger will make this number here go up 1. So our final answer should be 822.37. Wow, that's really messy. Let me just erase that. It's kind of hard to see all that. All right, retry. Okay, so 822.37, and our units again are centimeters, and we need to have a squared after them. Okay, this bottom cone, we have our slant height is 17.9 centimeters. Notice this time though, they gave us the diameter. That's the measure all the way across that circle. So our radius is going to be half of that, which is 4. All right, so then if we go to write out what we're going to plug into our calculator, it's 3.14, that's pi. Radius is 8 squared plus pi again, times the radius times our slant height. And again, grab calculator. And what you should get is 650.608. And again, if we're asked to round to the nearest hundredth, that's this place. I call this the boss when I teach. The boss is 5 or bigger, so it's going to pop that 0 up to a 1. So we're going to have 650.61, and our units are centimeters squared. All right, we have one more problem to do. And again, if you haven't done it yet, I challenge you to do this problem on your own and then come back and see if you got the right answer. So when we look at our picture, this here is our slant height. And again, they gave us the diameter on this, so we need to find the radius, which will be half of the diameter. 20 divided by 2 gives us 10. So just to remind ourselves what our formula is, pi r squared plus pi rs. So what are we going to type in our calculators? 3.14 times the radius, which is 10 squared, plus 3.14 times the radius times 22.4. So this one I'll do out by order of operations. Our 10 squared is 100. So we'll have 3.14 times 100 plus, and this here is all multiplication. So I'm just going to grab my calculator and just type that in. 3.14 times 10 times 22.4. That comes out to be 703.36. Now I need to multiply this before I can do that addition. That comes out to be 314. And then finally we can add those two together, and we're going to get 1017.36. No rounding here, so we can just tack our units on, and our units will be yards squared. All right, I hope that this helped. Again, it's a pretty straightforward formula. You just need to make sure you're working with the radius. So if they give you the diameter, cut it in half, and that they've given you the slant height. If instead of the slant height, they give you this height here, the perpendicular height, you're going to have to use Pythagorean theorem, but that would be the contents of another video, not this one. We won't go that in depth in this one. All right, I hope this helped.